Good morning, friends and dear students. It gives me immense pleasure to start a new course, which is project-based learning. This is my second lecture, which is elements of project-based learning. In first lecture, I have given some introduction and the different phases of the project-based learning. And I am Dr. Dwivedi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. In today's topic, I am going to discuss what is the PBL, then some research on the project-based learning, features of project-based learning, PBL roles, adaptation for the gifted, experimental design component, student experiment guide. So, project-based learning, introduction, and innovative model for the learning. And this I have discussed in my last also. So, about this is a quote from Gautam Buddha, and I think 2000 plus years of this, an idea that is developed and put into action is more important than idea that exists only as an idea. So, what is the crux of this quotation is, you can develop the idea, but you make it in practice. So, you develop it not as an idea, it is as a product. Make some new thing of your idea, and this your idea should be useful for any of the person. So, what is the PBL? So, an instructional method that challenges student to learn, working cooperatively in group to seek solution to real world problem. So, what is the meaning here? And this is an instructional method which is normally used in the school and the colleges, where an instructional method that challenges student to learn, working cooperatively in groups to seek solutions to real world problems. So, real world problem, everywhere this word is very important. So, a student has to learn in a group, in a community, in a good way, and they should solve some problem of the real world. Engages student curiosity and initiate learning the subject matter. Provides excellent opportunity for student to think critically and analytically, and to find and use appropriate learning resources. Promotes autonomous learning. So, what is the meaning here? Engage student curiosity. Try to develop that student is curious to learn and initiate learning the subject matter. Try to give some interesting stories so that student is able to have the interest. Provide excellent opportunities for the student to think critically and analytically. You give some opportunities, you give some topics like that, students should be able to start the critical thinking and how to do this thing, analyze the things, and to find and use appropriate learning resources. And by this, what type of learning resources from the net, from the things they are able to get. Promotes autonomous learning. You make sure that students are learning by their own. Interference is not required. Only some mentoring and guidance is only required. So, this project-based learning also gives the research on the PBL. Some research was done on the PBL and how this is useful. I have given some here researches by some of the people. So, in this, they have got some findings. These findings are depicted here, 2000, 2003 and 1997. Only I have given here this 3. There are so many others. Okay. So, students show significant learning gains in experimental design through a PBL approach. So it is when Tassel and Baska et al. 2000, they have done the research and they have find that a significant learning gains were obtained by the students. Next, research by Gallagher and Stephen, 1996. Gallagher and Gallagher, I think two brothers, 2003. They have also students show enhance real world skill with no loss in content knowledge as a result of using PBL. So enhance real world skills. That is the, but there is no other loss. They have find out that there is only gain, no loss of other thing. Third research is why students and the teachers are motivated to learn using the PBL approach. So it is also good for student, also the teacher, because teacher has to learn. Then only he or she can give the mentoring to the student. So it is 2000 by Van Tassel again. Students show enhance higher order skills. So I have shown the skills from remembering, understanding, apply, analyze, evaluate, and the create. So if you do the PBL work, the level of knowledge will increase. So this is also Dodd 1997. Now I will discuss about features of the project-based learning. So what are the features of this project-based learning? So this is the learning center. In this, not only teaching center, the project-based are the learning center. It is learn, get the knowledge. It is for the teacher also they are learning, students are also learning. There is no teacher. So here it is a learning center. Both the teacher and the students, both are learners. Both are getting the knowledge by doing project-based learning. Real world problem. The second feature of this thing is student will be able to understand what type of the problem our community, our society, our country, or our village or our state is facing. In India, if you see, every state and then every region has their own problem. So a student of that locality has to understand in my area what type of problems are there. In my school, my village, where my school is there, my college is there, what type of problem? We have the less water, we have the pollution, we have some polythene issues, we have some electrical issues, we have some other societal issues like schools are not good or the teachers are not teaching. So like this, some problems of the real world problem we have to find out from the local. Not a universal problems will not solve the problem. Teachers as a tutor or the coach. So here in this project-based learning, teachers are acting like a coach or the tutor, not as a teacher. Emphasis on collaborative team. Here, a collaborative means different friends, different groups, and different types of people are making together and they are doing the work. Employ meta cognitions. So in this, the skill level or the level, different big things are employed. Uses alternative assessment. In this, different types of assessment also can be used for the assessing the students. This will be very useful. Embodies scientific process. In this, scientific processes are also embodied. So, what are the roles for the teacher and what are the roles for the students? So, in this PBL project-based learning, the roles of the teacher and the roles of the students are clearly differentiated and both have to work accordingly. First, I will discuss about the teacher. The present and ill-structured problem act as a meta-cognitive coach. So, teacher has to give a draft, a rough problem. First thing the teacher has to do, teacher has to give a broad way that there is a village and in this there is a problem of water, there is a problem of the sanitation, there is a problem of like this, a rough big issue teacher has to say. number of issues, not one. Out of that, student will select what they can do. Act as a metacognitive coach. The teacher should have the capability to guide, to mentor the students, the child, so that they can ask the question, they can ask some issues which they are not able to do. Teachers should guide them properly, and accordingly these two main functions are there for the teacher. And what the students' functions or the roles? Create a precise problem statement. So a big problem is given by teacher, but student will give a very precise and very small problem, because big problem solving is somewhat difficult task. You have to take the problem which you can solve. So create a precise problem statement, find information to solve the problem, and then you do some research, you do some literature survey, read some books or some newspaper or some research papers or some articles. So you should get some information on that problem, evaluate possible solution, and then you find out some 2-3 solutions, and then you see that which one is the best. Then after this, you create a final product. So these are the 4 steps which students has to do. So here roles are very much specific. As I am also teacher, I am requesting all the teachers, please frame your ill-structured problem. A broad problem you have to give. Then you should be in that situation that you should able to guide, you should able to coach the student in a very big cognitive level. Means your level should be very high. Then only you will be able to communicate to the students. And this student have to do precise. They have to make your own problem statement, find the information by the literature survey, evaluate possible solution, and then create the problem. So these are the steps. Now adaptations for the gifted. Adaptation for the gifted. So in this advanced content, complex concepts, interdisciplinary connections, reasoning, habits of mind, and self-directed learning, ethical discussion. So these are the I have taken from this Gallagher 2001. So advanced content, then complex concepts, interdisciplinary connections, reasoning, habits of mind, and self-directed learning, ethical discussion. So advanced content means your problem should not exist in Google. You frame such type of issues which are not there in anywhere. So it should be advanced content. Complex concept. Concept should be complex, not so simple. You should have some complexity. Next is interdisciplinary connection. It is not only the one class. It may be from other college, other school, other people is involved. Other branch of engineering, electrical, mechanical, aeronautical, civil, computer science, all can jointly do the work. Then reasoning, habits of the mind, and self-directed learning, reasoning capability, your mind states, and ethical discussion. It should not be theft from somewhere. Whatever work you are reading, you give the proper credit who has done. Don't, if it is not your work, don't say it is your work. You just give, just like here. This is not my slide, and I have taken from here. I have mentioned here. So like this, we have to mention from where you have taken the content. Now, comparison. So, characteristics of the gifted and characteristics of the PBL. So, 2 types of things are there. So, in this characteristics of the gifted means desire for self-directed learning. Gifted means what? It is self-talented. You have a lot of things, because in every class you have the 60 or 40 students, out of that 5 to 10 will be really gifted. They don't need any much support. They will do their own work. So desired self-directed learning. So like this type of students, they are self-directed. We need not to mentor also them. Intense curiosity, they have a lot of curiosity for the learning of what is the real issues. They will find out. Then meta-cognitive thinkers. They are the meta-cognitive, the high level of thinkings are there. But the PBL is, students are in the charge of the learning, requires problem finding. They need to find the problem. Have you considered all the possibilities? What assumptions are we making? Why is the strategy not working? So in this project-based learning, this all another level of thinking you are getting. So it is a gifted means what? Here it is a self-knowledge is there. Level of knowledge is more. So for them, these things are existing, and the project-based learning by doing, these things are required. So here some scientific habits of any human mind, this cognitive skills, affective skills, and attitude. So in this, mind will have the curiosity to learn. Mind will be trying to find something new. Creativity. Mind will also try to make something new product, new thoughts, new idea. Then it will also have the objectivity. Mind will also have the openness to the new idea. Now, mind should have accept the new idea. Not just a very congested, I will not accept. Oh, this is not good. No, first you see it and understand. If it is not good, you reject it. But just blindly don't reject. Mind also has the skepticism, tolerance for ambiguity. Your mind should be able to wear the ambiguity. Any conflict is there, try to tolerate it. Don't just make more ambiguity. Try to observe it, and then you take the decision. Mind should be able to take the decision what type of decision is required. Experimental design components. So in this, what are the components required for the experimental design? In this, we need independent variable. If you want to do some experimental work, you need some independent variable. So what is this variable? Manipulated X variable that is purposefully changed by the experimental. So if you see here, this is the X and this is the Y. So this X is changed by the experimenter. This is changed by the experimenter. And Y you will achieve. Dependent variables are what? Responding, this is the Y-axis. Variable that may be affected by the independent variable. So try to make your independent variable here, and if you see here that if you do some wind tunnel testing, so we will vary the angle of attack here 2, 4, 5, 6, and here is the lift. So this is the independent variable and this is the dependent. Okay, so like this you have to form. Then you have to frame the hypothesis. So first you have to find out the independent variable, then dependent variable, then you find the hypothesis. Hypothesis means a prediction about the relationship between variable that can be tested. So x-axis and the y-axis, and you find that if x-axis is increasing, your y-axis will increase. This is a hypothesis. It may be correct or it may not be correct. Next is the constants. All factors that remain the same and have a fixed value, that is called the constant. What is the control? The standard for comparing experimental effect. So this is the control on our experimental technique. Then repeated trials, the number of experiment repetition, objects or organisms tested at each level of the independence variable. So we have to conduct many number of experiments, and then you see that each experiment how much variation of independent, these dependent variables are taking place and whether it is acceptable or not. So it is experimental design, and these are the components which we all have to learn before we proceed for any project based learning. So experiments, students, experiment guide. So practical questions, what are the practical questions which we have to understand? So first one is the proposed experiment feasible? First question, is the proposed experiment feasible? Next question, what material will be needed? So for this experiment, what material we need? How can we use these materials to help us find out? So how this material will be useful? Can we do the proposed experiment given what we have? So presently we have these items. Can we do the experiment? No. If no, what additional items required that you can find out? Which experimental approach is best given the time and the material? And we have to find out that with the given resources, given money, and given the time frame, which experiment I will be able to perform and I can get my result. So these are called the practical questions. Now planning questions. So you have to plan the work and you have to answer the planning questions before you start the work. How can we be sure that our experiment is giving us the right answer? So how we know that our result which we are getting are correct? So it means we have to find out some other existing results and we have to compare. If we are able to compare one or two values, it means our method is correct. So what do we need to change to get our answer and why? So we have some question, we have to give some answer. So what we need to change so that we are getting the correct answer? That the configuration, the construction, the methodology, the inputs, we have to change it. What has to say the same during our experimental and why? What has to stay the same? So what the parameter will remain constant in our experiment and why? We have to answer these questions. What data need to be collected and why? So which type of data we have to take from the literature survey, from the other material, from the other resources, we have to get some data and why we need this data. It should be very much clear. How can we make sure we don't accidentally foul up the experiment? We have to make sure that we should not do a false experiment. It should be a good experiment which we should be able to perform and which we should be able to get the answer. So student experimental report. So how to make the experiment report? So title of the experiment, you have to write it here. Then you have to write the hypothesis, means educated guess about what will happen. The hypothesis means it is a idea that if you vary this thing, this will happen. So this you have to write here. What type of hypothesis you have used? Independent variables, the variables that responds to change in the independent variable. Then observations and measures to make. So what the observation you have to make it, that you have to write down here. Constants. So what constants you have observed? All the things, factors that remain the same, like your atmospheric pressure or some other conditions, your humidity, other things are constant. Control the standard for comparing experimental effect. So these things you have to write in this type of report. Demonstration versus experimentals. What is the difference between the demonstration and experimentals? So useful in illustrating a concept idea serves as a springboard for further experimentation. So demonstration means showing the prototype. So useful in illustrating a concept and idea. So you just show that, oh, this is like this, like this, like this. Serves as a springboard. It is a springboard means it is a model in which we can do the experiment. So what is the experimentation? It is integral part of the experiencing science. Forum for student inquiry addresses higher order thinking skills. So these are the experimentation. These are the experimentation. And this is the demonstration. So in the next lecture, I will be discussing about introduction of the PBL, approaches in the PBL, steps in the PBL, teamwork, and the project description. This I am going to discuss in my next class. This is a reference which I have taken from here. Any questions you are welcome to ask. I will feel very happy if I am getting any question. Please do like this YouTube channel and also subscribe and give the comments in this my channel. This is my email. Okay, so this you can send me in this mail. Thank you very much for joining. Please do like and see my next video. It will be again further very good and then knowledgeable. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.